Hello all, this is Akshit Priyas and today we will understand what is TensorFlow and how to train our neural network using TensorFlow. And before we begin, we should understand that TensorFlow is an open source library which was developed by Google in 2015, and before 2015 it was for Google internal purposes, and now it's available for all. So we are using as of now TensorFlow 2.4.1 version. As of now we already know that TensorFlow is all about machine learning library. So before going further, we should understand two things, one about classical programming and other about machine learning. So actually deep learning is subset of machine learning. So in order to understand deep learning, we should get a little bit idea about what is machine learning. So actually in classical programming, we give data as well as rules and we will get outputs. As you can see in this picture, here, the data and rules are explicitly programmed and we will get output as answers. But the concept in machine learning is different. Here we will give data as well as answers and we will find the rules. So machine learning is all about finding the rules. So as deep learning because it is subset of machine learning. So today we will train a single layer neural network, and before we begin we should understand that all the neural network consists of three parts. One is input layer, another one is hidden layer, and third one is the output layer. So it looks like this. One is hidden, one is output, and we give input. So if the hidden layer is present in multiple numbers or greater than one, then it is called a deep learning neural network. We have understood as of now that machine learning or deep learning is all about finding the rules from the data. So we can see that here there is rule of conversion from Celsius to Fahrenheit. F resembles Fahrenheit equals 9 by 5 into Celsius plus 32, and we will see that whether this rule can be generated by our machines by looking only the data, not implementing this actual rule of conversion. So here you can see that there are two sets of data points. One resembles Fahrenheit and another Celsius. And I have created this data points by using this rule for conversion of Celsius to Fahrenheit. And we will check that whether our machine learns this rule or not depending upon the data. So we will show only data to our machine and see that whether our machine is able to learn. And so that is all about machine learning. So we will start coding as of now. So let's train our neural network using this data point. So first of all, we will connect our Google Colab. So I am using Google Colab. You can use Jupyter or you can run Google Colab in your respective phone. So let's start, and I'm going to import TensorFlow library, and we will check the version of TensorFlow first because we will be using TensorFlow code that is suitable for only version 2 or greater. So let's check that. So we have imported our TensorFlow library and we will check the version of the TensorFlow first. So let's print that. So if it is greater than 2 or 2, then it's fine. So it is absolutely fine as of now. You can use Alt Enter or you can use the plus button for new line space for coding or new block. So after importing TensorFlow, we should import Numpy, and because of its important feature and dimensional array, and we will going to use that. So let's import that as well. Now I've imported our Numpy library, and let's create our two variable sets, one for Celsius and one for Fahrenheit, using the data points that I have shown here. So let's create it. And the data points are -40, -10, 0, -40, -10, 0, 8, 15, 22, and 38. Absolutely fine. Now we should also assign the data points. because our output can be a float, because we were using this fraction for conversion of our data points, and we need to identify that whether our machine is learning or not this equation of conversion. So we will use d type as float. And let's take another variable, that is Fahrenheit. Here also we will use NP array. This is the best feature of Numpy, and that is why Numpy is very famous for. And this is also going to be minus 40, 14, 32, 46, 59, 72, and 100. And here as well, the type is going to be float. You can use Alt plus Enter for running your code, or you can simply use this one. So now we have our data sets. We can visualize it if we have not understood that what kind of data set and how it is related. So now we have the data set. So we can use enumerate function to visualize it further, or we can't use also, but this is optional for those who are not understanding that how this conversion is for. So I'm using it, let's say, but this is optional. So this is a function in Python, and it is used for yielding a pair objects. So you can see here, let's pass Celsius into it. You can see that it will return an enumerate object, and the iterable must be another object that support iteration, and the enumerate object yields pair containing a count. So we have a pair of Celsius and Fahrenheit. So let's pass one. So I am passing Celsius over here, and we will use the formatting, or you can use F. You are your Python version is greater than 3, or you can use dot format. So any of your choice you can use. So I am using dot format, so it is conventional. So let's write it down. So this step is not necessary, but I am writing for the ease of understanding. Let's pass one placeholder, and in this placeholder we should uh, let's say degrees Celsius equals to another placeholder, and that is for Fahrenheit. And let's pass our I into it, or you can see that Fahrenheit, and we will use the format, and we will pass C and Fahrenheit to it. So now it is fine. Let's run that. So as you can see that minus 40 degrees Celsius equals to minus 40 degree Fahrenheit, and similarly my 38 degrees Celsius equals to 100 degree Fahrenheit. So now we have our data sets. Now we will start training our data set. Let's create one layer, and this is all about layer that I was talking previously. So let's say So I am importing Keras library. So Keras is also a deep learning library and it was developed by Francis Collett and he was employee of Google, and in 2015 it was also made public, and there is now a stable version of Keras to 2020, and this version is 2.4.1. So let's import our Keras. So tf.keras dot layers. You can see that there are different layers of Keras, and I am importing the dense layer. And after importing dense layer, we need to add and give some variables like units. Units resembles number of neurons we are using. So here let's say 1. So it is single neural network. And after units, let's decide the input shape, what input we are giving. And this is also a one-dimensional array. So let's say 1. Now our layers has been decided. So now it's time to compile our model. So to compile our model, we will use model.compile. It is a function in Keras. So let's use that. Model basically resembles this variable that I have created. It can be anything, model 1, model 2, xyz. So I have written the variable name as model. So I'm using model.compile. You can use anything of your choice. Let's say that model.compile, and we will give loss function as well as optimizer over here. You can see that. So but let's decide first loss function. There are many kinds of loss functions like mean squared error, root mean squared error. So we will use mean squared error over here. So it is all about the difference between the predicted output and the actual output. So let's say, and it is squared because to, if there are negative values, if the difference is negative, then if you will square it, then it will be coming positive. So hence there will be not any bias present in your model, so your model will be accurate. Now we have loss defined. Now you can say that you can here define the optimizer as RMS prop, loss, matrix. So let's define our optimizers. Optimizer equals tf dot keras dot optimizers, and from optimizers I am importing atoms. So there are multiple optimizers that are present, such as gradient descent, stochastic gradient descent, batch gradient descent. So I am using over here atoms. As you can see that atom, and we will give our learning rate as 0.1. One variable named history, or you can use any variable over here. And uh, let's fit our model, and we will pass Celsius as well as Fahrenheit. Now we have passed Celsius and Fahrenheit. Here we will also see what is the number of epochs. Epochs is the number of times we present your data to your machine. So we have here suppose 7 data points in the example. You can see over here. So we have only 7 data points, but we will present these 7 data points to a large number to a machine so that it will be able to find the patterns between the data and what is the actual rule it will be able to find. So how many number of times the data is presented to the machine is called epochs. So we will give epochs, let's say 500. And verbose is all about if you want to see how your model is getting trained, then you can put verbose equal to true. If you don't want, then you can use verbose equal to false. We will use both of them. Let's say verbose equal to false. So now we have fitted our model and let's run it. You can see that it got executed without error, but when you will turn verbose on, you will be able to see how your model is getting trained. So as you can see that our loss is getting minimized. So see, you can see here every time our loss is getting minimized. So in order to not to see these much things, so we will put verbose as false. It's all about the learning rate, how our models is going to perform. It will show 500 times into 7 means 3500 times. So it's false is fine. So now we have trained our model and you can see the analytics by using matplotlib. So it is again optional, but again I am doing it. Let's type percentage. To see the image over here, we should write matplotlib inline. If you will not write matplotlib inline, so there will be different outer face, or you can say that there will be the image will open in different window. So in order to avoid that, we will use always matplotlib inline. So now let's plot the x label as well as the y label. And an x level we will see the number of epochs. So how our loss function is affected by the number of epochs. So let's say epochs number. You can write anything, epochs number, but epochs number is fine. And let's decide our y-axis. And here will be our loss magnitude. So now it's fine. So now let's pass our x-axis and y-axis into the plotting part. So let's passing the history, and which is the training history that we have trained as of now. You can use any variable of your choice, whatever you have used here. So you can give the names. It is not mandatory to be history. So let's pass history, and then we are taking loss function from the history. So let's take the loss function. So now you will be able to see how your loss functions. It's again error, history is not defined. Type error. History is not defined. Okay. History dot history. Absolutely fine. So now you can see that your loss is getting increased as the number of epochs is increasing. So at last the 500, so you can see that change in the loss function is constant, so we can say that our model is performing good. So now let's see how our model actually performing by checking the output or predicting the next Celsius or Fahrenheit. Let's say for predicting, here also is the same model.predict, and we need to predict, let's say, for 100.0. It's coming to 11.7474. So let's see whether our equation is satisfied or not. So our equation was F equal to 9 by 5 into Celsius plus 32. So let's check that. 9 divided by 5 equals to 1.8 into 100 equals to 180 plus 32. So it is coming 212, and our machine is predicting 211. So our machine is learning. So it's all about the machine learning. So now we can say that our machine is learning, and as we have already seen, the rule machine had identified without seeing the actual equation, and it identified the equation closely, and our result is very much good also. It should be 212, and it's coming to 11.74, which is a good. So thanks a lot. Stay connected and do like and subscribe if you want. Thank you.